Hello and welcome. I'm Professor Julie Davis at Brunel University of London in Brunel Business School, and I'm Professor of Healthcare Management and Leadership Development. This quick YouTube video is about systematic reviews and meta-analysis, how to conduct them. This pyramid shows increasing reliability and utility of different types of evidence. So at the top, you have systematic reviews and meta-analysis. What is a systematic review? The purpose of a systematic review is to collect all possible studies that are related to a given topic or design, and to explore these reviews and analyze their results. And in doing so, you bring more reliable insights than just focusing on one study. A meta-analysis is mainly conducted on randomized controlled trials, RCTs, which have a high level of evidence. Preferred reporting items for systematic reviews and meta-analysis, PRISMA, is used to follow the process rigorously and systematically. What are the differences between a systematic review and a meta-analysis? Essentially, a systematic review is an objective, reproducible method to find answers to a certain research question by collecting all available studies related to that question and reviewing and analyzing the results. A meta-analysis, in contrast to a systematic review, uses statistical methods on estimates from two or more different studies to form a pooled estimate. You might choose to do both. So this example here uses a systematic review and a meta-analysis in looking at diagnostic efficacy of advanced ultrasonography imaging techniques in infants with a particular condition. This table is useful to compare a meta-analysis with a systematic review. So we look at definitions, what you identify in each, the aims, heterogeneity, and focus. So as I said earlier, a meta-analysis is a statistical analysis that combines the results of multiple scientific studies, whereas a systematic review is not a statistical analysis, but it gives a high-level overview of primary research that is focused on the same question that you're looking at, and it synthesizes high-quality evidence relevant to your question. So in a meta-analysis, you have a particular protocol. In a systematic review, you're looking at relevant studies and critiquing them. So the aim of a meta-analysis is to determine whether an effect exists which is positive or negative, and to obtain a single summary estimate of the effect. On the other hand, a systematic review is more general. It's to summarize all the findings within available evidence to help you reach decisions. So a meta-analysis is a statistical test to study heterogeneity and investigate explanatory variables. Systematic review, in contrast, just looks at the different factors that explain heterogeneity. So the focus in a meta-analysis is quite limited, whereas in a systematic review, it's more comprehensive and it focuses on a specific research question rather than statistical analysis. Clearly, this PRISMA model is very important, and it's important to look at the PRISMA 2022 statement and familiarize yourself with the various steps in the preferred reporting items for systematic reviews and meta-analysis structure in PRISMA. Do therefore familiarize yourself with the transparency reporting in systematic reviews and meta-analysis website that explains why you should use PRISMA, who should use it, and how to do it. There's a checklist for you to follow and subheadings that you can report your results. So you need a title of your systematic review or your meta-analysis, an abstract, introduction, methods, results, discussion, and other information sections. Rigor is absolutely important when you're conducting research, as well as relevance, and PRISMA is a great tool to help authors ensure that they follow systematically a particular process using predefined eligibility criteria to address a specific hypothesis. Clearly, you need to show this visually, so this PRISMA flow diagram visually summarizes the screening process steps. So initially you record the number of articles you find in particular specific databases so that this can be replicated. You show the decisions you make at various stages and the number of articles that were included or eliminated as you progress. Here again is a flow diagram that you can reproduce according to the filtering process you use in your own systematic review or your meta-analysis. If we look at the steps in more detail, to start with, you need to formulate your research question, which you can do with participants, previous literature, making comparisons, looking at outcomes. You may publish your protocol, register this. You need to define your inclusion and exclusion criteria, carry out your literature search, whether it's academic or grey literature, reflect on the quality of the evidence, any contradictions and contested evidence, extract relevant data, analyze it, consider different levels of assessing the evidence, and then present your results. The Cochrane collaboration tool is useful for assessing the risk of bias. So here are some examples in a table of aspects to look at. So you might consider the method used to generate the allocation sequence in sufficient detail to see whether it's reproducible in comparable groups. There may be issues of author's judgment and selection bias. There are issues of the methods, of the measures, whether it was a blind study or not, and who is doing the assessing. Are the outcome data complete? What about attrition and exclusion from the analysis? Was there any selective bias by the review authors? Are there important concerns of bias that are not addressed in the literature? And are there particular questions that could be expanded on? When you're carrying out a meta-analysis, it's useful to look at a forest plot. And in this example, you are analysing here two different models using the same data. So there's a fixed effect model and there's a random effect model. And the figure depicts individual trials as filled squares with a relative sample size and the solid line as a 95% confidence interval of the difference. The diamond shape indicates the pool estimate and uncertainty for the combined effect, and the vertical line indicates the treatment group shows no effect. Here's another example of a forest plot. So it's a geographical display of estimated results from a number of scientific studies that address the same question, and it gives the overall results. So you've got 5 studies there. The forest plots can take several forms. They're commonly presented with 2 columns. The left-hand column lists the names of the studies, commonly in chronological order from the top downwards. So you've got 91 to 2009 in this case. And then the right-hand column is a plot of the measures of the effect. For example, an odds ratio for each of these studies, often represented by a square, incorporating confidence intervals represented by horizontal lines. So the ratios or other ratio-based effect measures are shown at various confidence intervals. The overall meta-analyzed measure effect is often represented on the plot as a dashed vertical line. The meta-analyzed analyzed measure of the effect is commonly plotted as a diamond, and the lateral points of which indicate confidence intervals for this estimate. Clearly, any method has limitations. So Anne and Kang talk about this, that in a systematic literature review or meta-analysis, if the quality of studies is not properly evaluated, or if proper methodology is not strictly applied, the results can be biased and the outcomes can be incorrect. So you need to implement them properly to look at the results critically and to have an understanding that evidence-based medicine is changing constantly, and the number of systematic reviews and meta-analysis will obviously keep increasing. And you can't just indiscriminately accept the results of meta-analysis. You have to have a critical eye and to develop questions about the accuracy of understanding what you're looking at. Here is a useful table that provides a checklist of the kinds of items you want to discuss when you're talking about a systematic review with or without a meta-analysis. So what's the title? Abstract, structured summary, introduction, rationale, objectives, methods, protocol and registration in the articles you're studying. What are the sources of information? How have you done the research? How did you select the studies and filter some out? What was the data collection process? What are the data items? What are the risks of biases in individual studies that might be combined when you collectively bring them together? You need to summarize the measures and synthesize the results. In addition, you need to consider bias across studies and the need for additional analyses. Have a critical eye for the results and how you've selected the studies. What are the characteristics? Maybe some you should discard. Look at bias within studies and between studies, and really come up with solid conclusions. And also it's important to look at where the authors are based and how they're funded, and if they have particular conflicts of interest themselves. This again is another flow diagram of information through the different phases of a systematic review that you can follow, starting with identification, looking at screening, eligibility, and then what you have actually finally included. Previous studies may have followed quorum checklists, and now this is a table that shows how the PRISMA checklist improves on that approach in terms of objectives, assessment of bias across studies, and funding. You may also find the PICO framework helpful. This shows each variable to understand population, intervention, comparator, and outcome. Findings may also be shown visually. This example by Alan Mackay and others looks at over 1,000 cases of pediatric high-grade glioma and diffuse intrinsic pontine glioma, and they segregate the different mutations visually and cluster them from the various studies that they've synthesized. It's becoming easier in some ways, or more overwhelming, to use AI tools for research. So Jenny AI is tailored to academia. You may explore that as a tool, and also SciSpace provides very helpful tools to help you do your literature review. But of course, you need to put in interesting questions, and you need to make decisions about which literature is relevant, and you still need to read articles yourself. Ryan is another source of doing very quickly systematic literature reviews. I've listed here various YouTube resources where you can look at how to do systematic literature reviews and meta-analyses, details about PRISMA, comparing the differences between the two, and writing them up. Finally, here's a list of articles of examples of how to do systematic reviews and literature reviews, and links to Prospero for systematic reviews, as well as various scales like the Newcastle-Ottawa scale for assessing qualitative studies and meta-analyses. It's important to carry out systematic literature reviews and meta-analyses, and being transparent about why you're doing it and the rigorous processes that you're following to ensure these are replicable. Thank you so much for listening to this short YouTube clip on conducting systematic reviews and meta-analysis. I wish you all the best with doing either or both.